5.05 is also about equations for circles in different forms. So we began in 5.03 with equations of circles in standard form. So now let's look at general form. So this is standard form on the screen, an example, because it has the parentheses and the exponents. That's one way that we can tell. So to get it into general form, we want to work through getting rid of the parentheses and the exponents and combining like terms. That's it. So remember that when you are squaring a binomial, if you need to, you can write the binomial twice. Then you can distribute each item, x squared times, and then x times -2 is -2x. We get another -2x, and then those two make +4. Then we can do the same process for the second binomial, the y minus 3. If we're going to square it, we can write it twice. So we end up with y squared minus 3y, another minus 3y, and then a plus 9. So you might remember that the patterns that occur. Now we have like terms that we can combine. So we have -2x and -2x. Together will make -4x. We have -3y and -3y. Together will make -6y. We also have +4 and +9, the constant terms that came out of those binomials being squared. So together, those make 13. So what remains is x squared, a positive y squared, and equals 16. Now we like to do some rearranging usually for general form. We like to put all of our exponents in order from greatest to least, and then also alphabetical. So that means it will be x squared first, then the positive y squared. Then counting down, so that means to the first power, the -4x, and then the -6y. Now this plus 13, you can choose to leave it on the left side. You can move it to the right side with the 16, or what you're going to see more often for general form is that you subtract the constant term from the right side to move it to the left. So 13 minus 16 is going to give you -3, and since we subtracted those, we have 0. So that is the general form for the equation of the circle that we looked at in the last video. Okay? The general form, no parentheses, no exponents. That is all just algebra. Now, reverse. What if you're given it in general form and asked to go back to standard? Again, you're going to need some algebra. So if you were asked this question, determine the center and radius of the circle with the given equation, they didn't give it to us in standard form. It is in general form. We're going to have to do the work to get it back into standard form. How are we going to get those sets of parentheses? Well, my friends, we're going to work through that lovely process called completing the square. Yay, don't you love it? Okay, so to complete the square, we're going to do it twice in each of these problems since you have two separate variables. So we're going to get all of our same variables together, so it's kind of doing it in reverse. So I'm going to put the x squared together with the 2x, and then I'm going to leave a space for the number that I'm going to use to complete the square. Then I'm going to put the y squared together with the -10y, and then I'm going to put a space so that I can complete the square. I also want to move my constant term. I'm going to subtract this 25 over to the right. So I've got -25 over there. Woo! Okay. So that was just kind of a bunch of things all in one step. Put your same variables together, leave room for the perfect square term that you're going to add, and move that number with no variable, called the constant, to the other side using addition or subtraction. Now to figure out what numbers are going to go in those blanks. That is when we call completing the square. To complete the square, we look at the middle number, the coefficient, the linear coefficient is what it would be called. We take that linear coefficient. So for the x's, the linear coefficient is 2, and for the y's, the linear coefficient is -10. So to find out what goes in those blanks, we take the linear coefficient, 2, divide it by 2, and then square it. We do the same thing for the other one. You can think of it as a negative, that's fine. -10 divided by 2, and then square it. Okay, so for the first one, we're going to get 1 squared, which is 1. That goes in this first blank. And for the second one, we are going to get -5 squared, which is +25. So whatever you put in the blank is always going to come out to be a positive value because you squared it. Now we have essentially created 2 perfect square trinomials. This one here is a perfect square trinomial, and so is this one. They are just separated by addition. Now, we cannot just add 1 and add 25 to our equation and keep it balanced. Whatever we do to the left side, we are going to have to take care of on the right. So I'm also going to have to add 1 on the right and add 25 on the right. All right. So if you want to go ahead and simplify the right side, we see that the -25 and the +25 cancel, and we're left with just 1. Back to the left side. These now, remember, what does standard form look like? It looks like this. X minus h squared plus y minus k squared is equal to the radius squared. So if I'm going to factor these back down, I need it to look like that general form that's up there. So I know I will have 2 sets of parentheses with exponents of 2 on the top. The shortcut for factoring perfect square trinomials is to take the square root of your first term, square root of x squared is x, the square root of your last term, and the sign of your middle term, x plus 1 squared. That's it. Let's do that again on the y values. The square root of your first term, the square root of your last term, and the sign of your middle term. You have now written the equation in standard form, and now you can find the center and the radius just as before. H is -1, K is +5, and R is the square root of 1, which is just 1. So the center is -1, 5, and your radius is 1.